All right, so I'm going to do a quick video on number 1 from our test review. So for this problem, we have the price charged for a hot dog at a Major League Baseball game depends on the price for a 16-ounce soda. So the table below gives us data for 21 Major League stadiums. So we see the team, we see the hot dog price, and the soda price. Now, we're going to go ahead and put this into our graphing calculator. And we're going to put the hot dog prices into L1, the soda prices into L2. So to get to our list, we go stat and then edit. And then, like I said, type in the hot dog prices in L1. I've already got mine in. Type the soda prices in L2. Now, let's say you have data in there that you don't want that data. Like I've got stuff in L3. I don't want that in there. Scroll all the way up, highlight L3, press clear, press enter, and it gets rid of all those data values. So it's important that when you're putting your data for your hot dog price and your soda price in your calculator, make sure you keep the values lined up. So for instance, the Angels, the hot dog price was $2.75 and the soda price was $2.29. So those need to be lined up because that's an ordered pair in our scatter plot. And so make sure when you're doing this for your test, make sure you double check that you've entered in the right numbers. So go through your calculator, take the extra minute to double check it. And one thing, like when I was double checking mine, I noticed like some decimal points didn't say. So like I had something that like said 255 instead of 2.55. So that was something that automatically told me I had something wrong. Always make sure as well that the bottom row lines up. So there should be 21 values in L1, 21 values in L2. Now, we're going to go ahead and make first let's look at these problems, sorry. The explanatory variable. So the wording of this is weird because they said that the hot dog price depends on the price charged for the soda. So because they put that in the problem, the hot dog price depends on the price charged for the soda. That means the explanatory variable is the price of the soda, and the response variable is the hot dog price. That means if we were making a scatter plot of this, we want L1, well, no, not L1 in our case, sorry. We want the soda price along the x-axis and the hot dog price along the y. So to make a scatter plot in our calculator, we go second y equals. And now you might have your plots still turned on because we've done some of this in class. If not, like see how I have plots off. I'm going to press enter on plot 1. It's blinking on plot on. So I'm going to hit enter so it sets that, so it turns it on. We want the scatter plot highlighted. Now here's where we're going to switch it around a little bit. Because my x variable is the soda price, we put the soda in L2 and put the hot dog in L1. So I'm going to switch these. So I'm going to press clear and I'm going to make my x L2 and my y L1. So for your test, if you're making a scatter plot on your calculator, just make sure whatever is the explanatory variable needs to be on the x-axis, whatever is the response needs to be on the y-axis. All right, so go ahead and hit graph. If your data looks funky, go to zoom and down to option 9. Because zoom 9 is zoom stat, so it makes a kind of a better window. So here we see our scatter plot. And if I scroll down on this review here, we want to know what is the direction, form, and strength. Eventually this will go away. There we go. All right, direction, form, and strength. So direction is either going to be positive or negative. So in our case, we can see our values as we read our graph from left to right, they're kind of increasing, right? And they're kind of close to a straight line or linear. So our direction is going to be positive. Our form is going to be linear. And the strength, remember, the closer the values are clumped together, the stronger they are. These ones are kind of a little all over the place. So I would say they're either weak, you could say moderate. Now we want to determine the correlation coefficient of R. So to do this, what we're going to do in our calculators, we got to go stat, maybe. Calculator wants to be slow. Oh, there we go. All right, stat, and then we want calc. And we want option 4, linear regression AX plus B. Now, remember we put our X list, we switched it in this case. We made that L2 and our Y list was L1. So if you need to change those, clear, and then you just do second 2. Your Y probably already says L2, so clear that out and then do second 1 because we want it to be L1. You might have to change this when you're doing your test. Most likely it'll be set up so you want your X to be L1, you want your Y to be L2. Scroll down and hit calculate. This gives us a whole bunch of stuff. Now, if you don't see your R and your R squared, what I need you to do is hit the second 0 and go to the catalog button. So if you don't see R and R squared, you have to do this. I think I had you guys all do it once, but if you've reset your calculator since then, it'll change it. You only have to do this once unless you reset your calculator, but you go to your catalog, so second 0 to get to that. And you scroll down until you see the D's, because we're looking for the word diagnostic. There we go. So we want diagnostic on, and we press enter, and then we just press enter again, and it says done, and then we're good. So then, once you've turned your diagnostic on, remember you only have to do this once. As long as you're not resetting your calculator, if you do this, if you've already done this, you should be fine, unless you reset your calculator. Now that we have it on, we go back to stat, we go calc, we go down option 4, linear regression AX plus B. Press enter. Make sure your X list, in our case, is L2, your Y list is L1. That's probably going to be switched for your test. Hit calculate. Now you should see your R and your R squared. So our correlation coefficient is R. So in that case, that is 0.28. I'm going to round to 3 digits, 0.285. Well, I did it wrong. I read the wrong one. R is 0.533, which is kind of in the middle. So remember, correlation coefficient is a number between 0 and 1. If it's 1, that means all the numbers are the same, that your numbers are really close together and it's strong. If it's 0, that means your numbers are spread out and it's very weak. This is kind of in the middle. That's why I said that 0.5, you could say weak, you could say moderate as well. So that value is weak or moderate. The proportion of variation is just R squared. So in our case, that is 0.285. Part F is where we're going to determine the line, the least squares regression line. So that is y equals ax plus b. And we look up here at our chart, we see our A. Our A is 1.218. I rounded to 3 decimals. And our B is negative 0.181. So when we write our equation, it's similar to writing the slope-intercept equation of a linear equation, right? Y equals mx plus b. You guys have been doing that since freshman year. This is similar, except for we changed it to y equals ax plus b. So what do? We leave the y. We plug in 1.218 for x, or sorry, for a. We leave the x plus b, so plus negative 0.181. That means this is your least squares regression line for predicting hot dog cost based on soda cost. So the last piece of this problem that we want to do, get rid of some of this. All right, so that line was y equals 1.218x plus, or it could be minus. You could write that as minus 0.181. So we want to predict the cost of a hot dog if the soda cost is $1.95. So what that means is x equals $1.95. So we're going to plug that into our equation. We're going to say y equals 1.218 times 1.95 plus negative 0.181. I'm going to do it in the calculator for us. So 1.218 times $1.95 plus negative 0.181. Enter. So it means round it to 2 decimals because we're dealing with money. That tells us y equals, need more space. Y equals $2.19. So the soda price is $2.19. Now, is this a valid prediction? In this case, yes, because when we're thinking about a range of our data values, and if you look back at that beginning chart, we had numbers like basically $1.95 is within our range for a hot dog price. And we can kind of look at our graph even, or look at our data set. And we see like our hot dog price was L1. So we go from like $1.47 up to $4. So $1.95 is within that range. So that means it's good. Let's look at part H, because part H, we're going to ask if the hot dog price or if a soda price, which soda price was L2, and we see soda price, $1.95 is still within that range there. So we're going to see if $4.50 is. Notice there's no soda price that is beyond $4.50. Like nothing's bigger than $4.50. That means $4.50 is out of our range of values. So that means, whatever we predict here is not going to be valid due to extrapolation. Because $4.50 is out of the range of our current soda prices that we have.